Let's do an example looking at electrostatic repulsion for a pair of colloidal particles. So we've got some particles that are 100 nanometers in radius. They're 10 nanometers apart. They're in a sodium chloride solution of undisclosed concentration, but we are given the Debye length. So if we really need the concentration, we can just calculate it from that since we have the temperature and that it's in water. We also have the surface potential of the particles. Now when we do this problem, we want to know if we need to use the full-blown equation for repulsion or can use the high or low potential case, special case equation since they're much simpler. And looking at this voltage, we see that's relatively low. We know we were comparing in that hyperbolic tangent the top and the bottom of the argument, which are Z times E times the potential, and on the bottom we have 4 kT. And so basically, we're looking for this, a cutoff. A good rule of thumb for a monovalent salt like sodium chloride would be 100 millivolts. So we're well below that. So we're going to use the low potential case. All right, so let's write down the equation for the low potential case. So we're writing out the equation. We have 2 times pi times the radius times the surface potential squared, the two dielectrics. And then we've got this e to the minus kappa h. And of course, we could rewrite this if we want. Let's cross that off and rewrite this as minus h over the Debye length, since the Debye length and kappa are just reciprocals. All right, great. Let's plug in those numbers. All right, so we've plugged all these, and notice we've converted everything to SI units, except for up here where the 2 nanometers are going to cancel. Okay, so this will all end up, we look at this, we've got volts squared, we've got coulomb squared, so that's going to cancel to give you joules squared. We cancel one of those with a joule, so that leaves joules on top. Got a meter on the bottom, meter on top, those are going to cancel, and so we're left with units of joule. So this comes to 1.6, 10 to the negative 20 joules per pair.